In this video, we'll be looking at the properties of a parallelogram that involve the diagonals of the parallelogram. So, our parallelogram, as you should know, has two pairs of parallel sides. So we have that parallel to that, and this here parallel to this. All right, but that's not what I'm here to discuss today. What I would like to talk about is the fact that we have in a parallelogram two diagonals. So the diagonal is a straight line. That's my attempt at a straight line, but it should be a straight line that goes from one corner of the parallelogram to the opposite corner. So every parallelogram has two diagonals. So I drew them in this here. So we have both are parallelograms, and what they do two things that I want to mention in this video. The first thing that we need to know about our diagonals is that they bisect each other. What do I mean by that? I just mean that each diagonal, let me write this first. All right, I just mean that each diagonal cuts the other diagonal in half. So here, that side should be equal to that side, and this side here should be equal to that side. So that's the first thing we need to know about our diagonals. The next thing that we need to know about our diagonals, and I'll draw another parallelogram so we can see clearly here. All right, so the next thing we need to know about our diagonals is that if you have a diagonal, it's actually going to cut the parallelogram into two congruent triangles. So let's label it so we can see this clearly. Let's say this is A, B, C, and D. Then triangle ABD is going to be congruent, so the same angles and the same size. So it's going to be congruent to triangle BDC. And that's a given for every diagonal of every parallelogram. So, one thing you can do if you know something is a parallelogram, you can definitely figure out angles based on that fact, or you can go backwards and figure out if something is a parallelogram if there are two congruent triangles. All right, let's practice working with diagonals of our parallelogram for just a moment. Okay, so here we have a parallelogram and we have some unknowns, and we're being asked to find our unknowns. So the first thing that I want to do is find x, because it's probably the easiest and we asked for it first. So let's go ahead and do that. So we have that side, which is not only parallel but also congruent to that side, which means 27 has to be equal to 5x. So we can write that down. 27 is equal to 5x. Now we can go ahead and solve for x by dividing both sides by 5, and we get that x is equal to 27 over 5. And if you want to leave your answer that way, it's fine, or if you want to put it as a decimal, you can go ahead and say that x is equal to 5.4. All right, but that had nothing to do with the diagonals at all. But now we are actually going to explore the diagonals. So we know that the diagonals of a parallelogram have to bisect each other, which means that this half of that diagonal has to be equal to that half of the diagonal, which means then that we know that 2y minus 5 is going to be equal to y plus 4. When you know that, the rest becomes easy. We can go ahead and solve it algebraically. So we can go ahead and take y away from both sides, and we get that y minus 5 is equal to 4. And now we can add 5 to both sides, and we get that y is equal to 9. And now we're seeing some progress. All right, so the last thing that we're being asked for is z, and z is a part of this angle here. This angle is 3z. Now, we know that if these two things are diagonals of a parallelogram, then we know that our triangles QTS is going to be congruent to SRQ. Did I say that in the right order? I think so. All right, So we know that they are going to be congruent triangles. And you may recall from back in the day, a few months ago, we spoke about alternate interior angles. So that is also another thing that's telling you that the 3z here is going to be equal to 33 degrees. So we can go ahead and set that up and solve it. So 3z is equal to 33. And solving that, we can divide both sides by 3. And we get that z is equal to 11. And that's it. And that's how you deal with figuring out all these unknowns using the diagonals to help you.